I'm Anil Kumar, and here is an interesting question on optimization. We are considering rectangle in quadrant 2. The question is, a rectangle lies in second quadrant with one vertex at origin and two of the sides along coordinate axis. If the fourth vertex lies on the line with x-intercept at A and y-intercept at B, find the rectangle with maximum area. So we'll sketch and then read the question once again. So we have this coordinate axis. We are working in quadrant 2. What we're given here is kind of a line whose x and y intercepts is given to us, where it says x intercept is A and y intercept is B. What we are supposed to do here, we need to figure out a rectangle with maximum area which has four vertex, one at the origin, right? The other two on the sides of the coordinate axis, and the fourth one on this line, which has x-intercept of A and y-intercept of B. I hope that's absolutely clear, right? So that is the kind of sketch we have. Now you can pause the video, answer the question, and then look into my suggestion. Now, from so many examples, we have done similar kinds. You can expect the answer to be half of A times half of B, right? That is what is the answer. Let's see how to find that. This is kind of important. So I'll approach here by finding the equation of the line itself so that I directly get relation between x and y. So consider a point P on the line with x-intercept A and y-intercept B, right? In that case, what is the equation of line? Equation of the line in this particular case will be y equals to, it is y equals to mx plus b, you know that, right? So we have to figure out what is m. Slope is b over a, right? You rise b, run a. So slope is b over a, x plus y-intercept is b. So that becomes the equation of the line. Now what is the area of the rectangle? Area of the rectangle is this dimension. We have to take positive, all areas are positive, times that dimension. Now this is x for us and this is y, is it okay? So the area is x times y. You can write y in terms of x, correct? So what do you get? You get x times b over ax plus b. So what you get here is area in terms of x as a function of x. So we'll write this as b over a x squared plus x times b. So that is how you get a relation of area in terms of x, one variable. Now what can x be? So we'll basically now define the limits for x. That is what we are going to define. As you can see, x could maximum be a, forming a rectangle kind of like this. Do you see that? So x could approach a and become smaller and smaller. So one is x has to be greater than, we'll write first x should be maximum, it could be a, so it's less than equal to a. Second, it could be very, very small, but give you a rectangle which is kind of like this, right? So approaching 0. So x could be greater than 0 and less than a. So these are the two boundary conditions, right? So we need boundary condition to find what? Absolute, which is say maxima or minima, right? Now in this case, what do we have? Now if I write x equals to 0, that means area will be how much for 0? If x is 0, this term will be 0, this will be 0. So we get 0. If x is a, in that case, what happens? If x is a, effectively this is actually minus a, right? So if x is a, one of the dimensions, y is going to be 0, you can see that. So if x is a, y is 0, so that is also equals to 0. So area is 0 on the two extremes. Anywhere in between, it has to be positive, right? So that gives you maximum, more than 0. Perfect. So that's the kind of strategy. Now let's figure it out. So let's find the derivative. a prime x, which is 2ba over x plus b, right? Now, for critical number, that should be 0. Let's find the value of x. That means 2b over ax should be equal to minus b, or x is equals to minus b times a over 2b, right? That gives you minus a over 2. So that is the value of x. Since we are in quadrant 2, we are getting x values negative, correct? As far as the area is concerned, we have to take absolute values. Remember that. So what you get here is x is half of a. Do you see that? Now if I substitute this value of x in y, then I can get y value also. So let's write down y is equals to b over a times minus a over 2. Right? Let's get the coordinate points first, then we'll take care of negative sign also. So a and a cancel. So we get b over 2 with a negative sign plus b, and that gives me b over 2. So the coordinate points over here for x and y are, coordinate points are minus a over 2 and b over 2. Do you see that? So this particular rectangle has a point P at minus a by 2 and plus b by 2. So this point is b by 2 and this point is minus a by 2, right? Of course this value is negative, so I should have started with minus a anyway. So it has to be negative when you're on the left side of 0. But that gives you dimensions, right? So dimensions for the rectangle will be a by 2 units by b by 2 units. You get the point, right? So it is half of each, half of each. So it's kind of important to see that whenever you have a situation where ultimately you get a rectangle inscribed in a triangle, then for maximum area, dimensions of the rectangle are half of the sides of the triangle, right? So that is kind of the summary from this video. I hope you understand and appreciate it. You could have done alternate way also to find relation between x and y, that by using similar triangles. So b over a is equals to y over a minus x, right? So let me write it down for some of you who would like to use it sometimes. That is, you could use similar triangles. B over a is equal to y over this side. So we are considering that small triangle. Y over that dimension, that is a minus x. Do you see that? A minus x. Even then you get the same equation of line, and then you can continue solving it. However, I wish that you can find most of the time equations of these curves and then you can have a very general method for any kind of curve. That could be a parabola, hyperbola, circle, anything, right? You will get your answer solving in this fashion. Thank you and all the best.